Is it clear enough for you guys to see the text? Okay, so let's start. Actually, I have done this presentation previously in Cambodia MUM, but some of my students in Myanmar, they request the English version of this presentation. So I would like to redo it again for this presentation in English. First of all, about me. Most of you who joined this morning MUM, you know already. I'm Makito from Cambodia, and I'm the CTO at IBEAM. Currently, I'm also the MikroTik certified trainer and consultant. Also, my areas of interest are BGP, MPLS, and IPv6. So can say I mainly focus on layer 3, on routing. As you might know, for the internet infrastructure, I'm not sure this happened the same in Myanmar or not, but normally in Cambodia, we always have many problems. Maybe someone just cut your cable quietly. Sometimes my internet disconnect unexpectedly, and then I realized that my neighbor cut my fiber because they are not happy my fiber lay over their home. And maybe sometime when you are sleeping at night time, the electricity explosion, so it caused all the thing on the electricity pole gone. Or maybe sometime your ISP is in trouble. Your ISP might have problem, and then your internet is disconnected. So what should we do if the internet have so many problems? Some people, they did this. Number one, simply connect to two ISP, plug some user to ISP1's router, and plug another users to ISP2 routers. The key concept is how fast you can switch the cable. This might work if you don't need 24/7, if you don't need to fail over very quickly. But it might be a problem if you are on holiday with family and then your boss calls you, just go to office to switch the cable. Or maybe you can pay to your existing ISP for the secondary cable to your office. However, this is, I should say, maybe rich people, they might consider this because the secondary cable, it will stay idle as long as the primary is up. Or maybe some company, they request their own IP block and then they buy IP transit from two ISP. Some big company in Cambodia, they might do like this. And they do the load sharing and failover by BGP. What can we do if we want to have a redundant link, we want to have automatic failover, and we want the redundant link can be used at the same time when your primary link is using, just for better ROI, return on investment? I got many questions about this, how to use two links at the same time, because many people, they connected two links, but they don't want to put primary and idle. They don't want to waste the money. They feel they waste the money if they cannot use. But sometimes we might have limited budgets, or our boss is stingy. According to my experience in the industry, most of the engineers, they want to build the best network in the world. But most of the boss, they want to save the best money in the world. So sometimes you might not be able to choose the best solution. You might need to customize it according to your situation. Then perhaps we can set it up with MikroTik router. We can do the load sharing instead of load balancing. What you might need is two internet connection. Perhaps you can connect to two different ISP for better redundancy. If you connect to the same ISP, then when the ISP burn, everything gone, right? So it is better to connect to two different ISP, especially two different ISP that have different international gateways. Not required to have the same speed on both links, but it is good to have. If you don't have the same speed, you might need to think how much traffic you need to put to this link, how much traffic you need to put to that link. You need to calculate it properly, otherwise one of the link might full and another link might left. And you need a MikroTik router. It can be RB750GL if you are a small office. Also can be 951, UI2HND if you need wireless. If you require up to 300 meg, you can try with RB1100. For you guys, if you want to test it at your home, you can use the router you got today. Just use the free router that MikroTik offer you today, then you can try it. So, what's the difference between load sharing and load balancing? Many people ask me about this question also. Why they use different terms? If we talk about the definition, load sharing, it means you share the traffic to multiple links. You have 1, 2, 3, you share the traffic to the link. So who share it? You share it. For load balancing, it means we balance the traffic on multiple links. Normally, load balancing refers to some technology that the router itself might automatically do the balancing. You might not need to decide how the router balance. Just configure it and let it work. For the mechanism, load sharing mainly is PBR, or if you are running the ISP backbone, it can be IGP route linking or BGP routing policy. I think at the moment there is a BGP presentation. So with BGP, you can do many routing policy, and the presentation talked about the best path selection also. So with the best path selection algorithm, you can customize which link you want to use more, which link you want to use less. For load balancing, mainly it is ECMP, equal cost multipath, or link aggregation. Link aggregation in Cisco we call Ether channel. So in MikroTik, you also can do link aggregation with bonding. Just create a bonding interface and then add the slave interfaces to the bonding. However, our presentation here, we are talking about load sharing, so I might not go deep into the load balancing technologies. I just talk how to do load sharing if you have 2 internet links, and how to do the failover automatically. For load sharing, it requires explicit policy. As I said at the moment, who share the traffic? You share the traffic. So you, the admin, need to define the policy. What kind of traffic you want to put to this link? What kind of traffic you want to put to another link? If you don't define the policy, the router might not know how to share it. For load balancing, normally it operates automatically according to the technical spec. So if ECMP just try to share the traffic 50-50 automatically by the router, if you use link aggregation based on what you select, layer 2 hash or layer 3 or layer 4, then the router will automatically work. So for load balancing, you don't need to take care of the policy. For application, load sharing you mainly apply on the WAN link, because as you know, internet has many kinds of traffic. You might have YouTube, Facebook, Google search, or Google Map, or maybe just some text website. So they use different bandwidth. If you just share the connection equally, let's say you just put 2 connections to link number 1 and 2 connections to link number 2, then they will not balance. Then you might have problem when one of the link full. You might have the performance issue. That's why you need to have the policy for what you need to put into which link. For load balancing, normally we apply on the LAN environment or the service provider backbone. So if you are an ISP, you have a bunch of bandwidth, you have maybe 10 gig link between your router, then it is okay, just let the router work automatically. Actually, if we talk about the best practice in the ISP backbone, it is recommended to upgrade your link when your link is utilized more than 50%. Because normally ISP, you always need to have the backup capacity. Otherwise, some of your link fail immediately. You don't have another link to route your customer traffic over it. For the limitation, load sharing, it is hard to balance the traffic. And it requires more administration involvement on the policy. So we can say the administrator will be more tired at the beginning. So you need to think what you need to do, what you need to define for the policy. For load balancing, the limitation is it is not working very well when you apply on the WAN link of a netted network. I think currently, especially in Asia country, most of the internet users, they are behind the net. I think it is very rare that everyone use public IP and route directly to the internet. Even in other developed countries, even in Japan or Korea, also the users are behind the net. So if you use the load balancing, it will have problem. Let me show you what is the problem. Why don't we use ECMP and NAT? ECMP behavior, it is vendor specific. Some vendors, they do per packet load balancing by default. Some vendors, they do per flow load balancing by default. Per packet means you have two links. The router will put packet number 1 to link number 1, packet number 2 to link number 2, and then just do like this. The router try to balance it using the packet. Per flow means your router will put connection 1 to link 1, connection 2 to link 2. So let's say connection 1 you use Facebook, connection 2 you use YouTube, then might be connection 2 use more bandwidth. MikroTik does per flow load balancing and refresh every 10 minutes. So this is the problem, because actually not really totally MikroTik problem, because the ISP normally they usually apply the security filters on their provider edge. Provider edge means the router that ISP provides service to customer. So normally they will have the firewall rule, and then they said, if you are not my customer, you are not my IP, I will not let you go. So they allow only their own customer IP. So for example, I'm not sure in Myanmar each provider's implementation. For example, MPT, they might allow only MPT's IP can go through the MPT link. YTP might allow only YTP link, YTP IP to go on the YTP link. Because of this behavior, so it caused the problem. Because MikroTik refresh the load balancing result every 10 minutes. So it means if you have a connection longer than 10 minutes, after 10 minutes, maybe at the beginning your connection on link 1, it might go to link 2. But the problem is, when the ECMP path change, the NAT is not changed, because MikroTik router did the NAT on the first packet. So let's say you have an IP, a private IP, go to the internet, go to Facebook, and then when you go to the internet, the router will see which WAN link you are using. If the first packet is ISP1, then the router will NAT your private IP to be the ISP1's public IP. So in this case, you can imagine 10 minutes later, you switch to ISP2 already, but because the result is not refreshed. So your router still forwarding your packet to ISP2, but using ISP1's IP. Then ISP2 will see, for example, ISP2 is YTP and ISP1 is MPT. So YTP will see, why my network have an MPT IP come from my customer link? It is impossible, so I will drop it. This causes the problem. It makes the connection down. So it is not I say you cannot use ECMP totally if your network does not have the connection which is longer than 10 minutes, then for sure you can use it without the problem. But if you have the long connection like the video streaming, or maybe conference call, or maybe you have a lot of users downloading the files, then you might have problem if your ISP do the filtering. For sure, if your ISP did not do the filtering, then your connection still works. But it is the best practice to do the filtering. So why not link aggregation? Most ISP, they don't support link aggregation to customer. Some ISP might do if you pay a lot to them. So this is the reason why we don't use link aggregation. And also if you have two ISP, you cannot do link aggregation to two ISP. Link aggregation can only do to one ISP. So let's say if your ISP really offer you the link aggregation, it is okay. You can do two links to them and then they will do the ether channel for you. But if the ISP international gateway fail, then you will still face the problem. So actually it is not the best option for internet. It might be the good option if you are renting like DPLC or VPN, but for internet it is not the good option. And if the bandwidth on both links is natively unequal, let's say you have two links, but one link is 4 meg, one link is 2 meg, then when you do the link aggregation, the 2 meg link will always full, and then the 4 meg link will use only 2 meg always. Because when your 2 meg link is full, 50% of packet will lost. Then the 4 meg link also cannot go up to 4 meg. Now we will do the topology like this. We have a small router here in the middle, and then we have two users. Two users, they are 1.100, 1.200, and then the router is 1.1. They are in the subnet 192.168.1.0/24, and then I have two internet link. Internet link 1, it is the static IP with this public IP 28.6, and ISP2 I use the PPPoE with the IP 29.6. So be careful, the IP 28 is ISP1 and the IP 29 is ISP2. Now let's go ahead to do the configuration. This example is based on RB951. So if you have other router, maybe you have the different port number, so you just adjust the configuration according to the router you have. First, you need to download Winbox, and then connect both links to your router, connect your PC to the LAN port. These are very basic. I think most of you know already. And then you can log into the router with Winbox, download the Winbox and scan, and then find your router and then log in. If you are doing this for the first time, I would recommend you to reset your configuration, because I would not want you have any default configuration that would interfere your configuration on this. But if you are sure your default configuration or your existing configuration is okay, then you can skip this step, it is fine. It is not required that you must do it. So you need to configure WAN 1 and the LAN. Because WAN 1 and the LAN use the IP address directly, so you just simply go to IP address and then assign the IP for WAN 1 and LAN, it is fine. After that, for the static IP, normally we will need to add the route for it. You need to have a default gateway, so you go to the IP menu, go to the route, and then you create a default route pointing to your ISP gateway. Normally, if you are the static IP user, your ISP will give you what is your IP, what is your subnet mask, what is your default gateway. So you just fill in the instruction according to what your ISP gave you. Here we enable ping. and we set the distance is 1. The reason why we enable ping, because at the moment we said besides load sharing, we would also do the failover. So you need to detect. How to detect? In MikroTik router, you can enable ping on the check gateway. Then your router will ping to the gateway every 10 seconds. When your router ping to the gateway and the gateway did not reply within 10 seconds, it will be 1 timeout. So when 2 timeouts occurs, then the router will consider this route is unreachable. Then your router will fail over. Simply saying, your router will do the failover within 20 seconds. So if your ISP link is down, 20 seconds, your router will fail over to another link. For WAN 2, we will use PPPoE. The way of configuring PPPoE, it will be PPP, and then create PPPoE client. And then just select your modem interface, which port that you connect to your modem, maybe port number 2, and then just fill in your PPPoE username and password. The most important is here, default route distance 2. So it means that at the moment you put your WAN 1 is distance 1, and this one you put distance 2. It means that one is primary link, this one is the backup link. And then you can test the connectivity. You can ping to your ISP gateway, and you also can ping to Google. Maybe you can do a trace to Google, so you can make sure your primary link is WAN 1. When you do a trace, you see the first hop. If it is WAN 1's IP, then your primary link is WAN 1. After that, you need to configure NAT. Even you don't do load sharing, you also need NAT. Because now most of the users, they are using private IP. It is very rare for us to use public IP in the LAN. So just go to IP, firewall, NAT, and then create a new NAT role. Select change source NAT, and interface is your WAN interface. Our interface is your WAN interface, and action masquerade. Some students ask me, what is masquerade? I said you just simply understand it as NAT. If you used to learn CCNA, it is NAT overload on Cisco. Create a routing table for the wireless LAN 1, for the WAN 1, and then the way you do it, go to IP, route, point your default route, and create the routing mark, WAN 1. Don't worry about the presentation slide. I will upload it. So you guys, after the presentation, you can download it and then implement it at your home, step by step. The reason why I do it so detailed, because I want you to do it step by step. So basically, this is not a presentation, it is a lecture. Here you also need to create a routing table for WAN 2, and then you test your routing table. Make sure both routing table has internet. So let's check what we have done at the moment. We have configured the WAN 1 using static IP, and then we have done the LAN, but we did not do DHCP for the LAN. We point the default route to WAN 1 and set it as primary link, and then we set WAN 2 using PPPoE, and then we use WAN 2 as the secondary link, and then we do the NAT, and then we create a routing table already. So now, let's decide what kind of traffic you want to put to the link. Let's say you want to apply in your network the user with IP 192.168.1.2 up to 1.127 use WAN 1, and then the user from 1.128 to 1.254 use WAN 2, and the destination to Google use WAN 1, destination to Facebook use WAN 2, destination to DIX. This one might be a new word for you. DIX, actually it stands for Domestic Internet Exchange. It is the local network of Cambodia. I think in the future, Myanmar, when you have more ISP, you will have the internet exchange also. So all the traffic locally use WAN1. And then for the router itself, will not affect by any policy. According to our policy, we need to configure the router like this. We need to configure the router that the packet with destination IP 1.0/24 look up the main routing table. This rule is required. If you don't do this rule, then the traffic between LAN to LAN will not be routed correctly. And then you need to create a rule, the destination to Google, to Facebook, to DIX, which routing table that it looks up. You still remember at the moment I created two routing tables. One is for WAN1, one is for WAN2. So now when we define the policy, we just need to define which traffic you need to put to which routing table. And then for the router itself, just use the main routing table. When you choose main routing table, it means it is not affected by any policy. It just uses the default routing table. For the IP from 2 to 127, it is /25, so you use it on routing table WAN1. For IP from 128 to 255, you will use WAN2. I think now you might feel it is very complicated, but just follow the screenshot step by step. The order of the rule is important because the router will process from the top to the bottom. And about the IP address, some people ask, how I can know Google, how I can know Facebook? You need to do some marking, right? In the router, you need to have the IP address of the Google and Facebook. What we are going to do, we will do the marking. We will have all the IP of Google, all the IP of Facebook, and then we use the firewall mango to mark the route. We will mark a name. We will say, okay, for this IP, it is belong to Google. So we give it a name we call routing mark Google, and then you will use the routing mark in your rule. For the Google Facebook IP, if you don't know where to get it, you can get it in our Facebook group, or if you would like to collect it by yourself, it is also fine. Then this is the address list. If you download from our group, this is my group in Cambodia. If you download from our group, then you will get the address list, and then you can apply it to the router. Just simply copy and paste to the router, then you can have the Google address list. If you don't know how to copy and paste, go to the router, new terminal here, and then right click, paste. That's it. Then now you have the list of the IP already. You need to mark the traffic. The way of marking the traffic is IP firewall mango. Create the new mango rule. You can set the chain as pre-routing because now we are trying to do PBR, policy-based routing. So we need to set pre-routing. You cannot use post-routing. Pre-routing means happen before routing. Post-routing means happen after routing. So if you do PBR after routing, it is impossible to change the router decision. It should be pre-routing. And then go to the advanced tab. Choose the Google address list that you download from the Facebook group at the moment as the destination address, and then mark routing as Google. Now you have the routing mark, the name Google. And then you create the rules. Before you start to create the rule, make sure your routing table looks like this. You have a default route in the main routing table, point to 2 of your internet link, and then you have routing table WAN1, routing table WAN2. So totally you need to have these 4 routes, these 2 and these 2. Make sure you have these 4 routes. Then you can start to do the rule. The way of configuring the role, you go to the tab roles and then create a new role. Here, destination IP 1.0/24. This one, it is our LAN traffic. LAN traffic should not do any policy because from LAN to LAN should be routed natively on the default routing table. Should not be policy-based routing. Otherwise, if you don't set this rule, the traffic from 192.168.1.2 to 192.168.1.200 will route through the internet, not through the LAN, because you will have other rule to force them to go to internet. For rule number 2, you need to create routing mark Google lookup routing table WAN1. For rule number 3, number 4, you will do it the same way. Rule number 3, routing mark Facebook, go to WAN number 2, routing mark DIX, go to WAN number 1. Basically, in IP route role, you just simply define which traffic you need to put to which routing table. So the purpose of creating the routing table, it is for this routing rule. And then rule number 5, your router, just look up the main routing table. Rule number 6, the source IP 1.0/25 will look up routing table WAN1. 1.128/25 will look up routing table WAN2. So totally you will have 7 rules. Maybe this one is a bit easier to understand. The 7 rules tell you, the first one, if the LAN traffic, don't use PBR. If the Google, then go to Internet 1. If Facebook, go to Internet 2. If local traffic, go to Internet 1. And then if it is the router, don't apply the policy. If it is your LAN from 1 to 127, go to Internet 1. If it is your LAN traffic, it is your LAN IP 128 to 254, go to Internet 2. So the router, when it forwards the packet, it will process from the top to the bottom. When the router processes the packet, it will see whether you are the LAN traffic or not. If yes, you stay in the LAN, don't go to Internet link. Whether you are Google or not. You are Google, then you go to link 1. Whether you are Facebook or not. If yes, you go to link 2. Something like that. If you are not Google, you are not Facebook, you are not DIX, then what is your source IP? If your source IP is 1.100, then go to WAN1. If your source IP is 1.200, go to WAN2. Now we finish the configuration. We can do the end host connectivity test. You can simply do a trace route to Gmail. Gmail is the IP of Google. So if you do it, you will see your Gmail is go through WAN1. If you do a trace to Facebook, you will see Facebook is through WAN2. If you do a trace to the local IP, which is the DIX that I mentioned at the moment, it will go to WAN1. If you do to Yahoo, it will go to WAN1. The reason why go to WAN1 because Yahoo is not Google, it's not Facebook, it's not DIX. So Yahoo will check what is your source IP. If your source IP is 100, go to WAN1. If your source IP is 200, go to WAN2. If you use the source IP 200, then you will see different results to Yahoo. It will go to WAN2, not WAN1 anymore. Because in our rule, we said only Google go to WAN1, only Facebook go to WAN2, only DIX go to WAN1. For the other traffic, we will look up the source IP. So in this case, Yahoo, it will look up the source IP. The source IP is 200. 200, it is in the rule at the bottom. Just go back and see. 200. Here. In this slide, if you are IP 200 and go to Yahoo, the first one, you are not going to your LAN, you are not going to Google, you are not going to Facebook, you are not going to DIX. So it will check the source IP. You are not in this subnet, so you are in this subnet. That's why need to look up WAN 2. This is the reason why IP 200 go to Yahoo through WAN 2. Alright, so I have finished my step-by-step presentation. I think most of you, maybe you are still not clear until you try it out by yourself. So it is better for you to download the presentation file and then just try to get 2 internet connection. Maybe you can get one MPT and another one is 3G. It is fine. It does not matter what kind of internet connection you get. And then you just try it yourself, then you will understand it. Otherwise, I think it is very short time for 45 minutes to explain everything. You guys might think, hey, what is role? What is routing table? What is distance? Right? What is mangle? What is routing map? Many things you might need to research it more, because actually all of those are in the topic of MTCRE. So it is not a very basic knowledge. So I think maybe you take some time to research it or to know what is this, what is that, then finally you will understand every step of the configuration. Do you have any question? Yes or no? No? Okay, so thanks for your time.